Let us have an example. Discuss the intensity of transmitted light when a Polaroid sheet is rotated between two crossed Polaroids. Let us have the solution. Let I naught be the intensity of polarized light of the passing through the first polarizer P1. Then the intensity of light of the passing through second polarizer P2 will be I is equal to I naught cos square theta by 2, where theta is the angle between pass axis of P1 and P2. Since P1 and P3 are crossed, the angle between the pass axis of P2 and P3 will be 90 degree minus theta. Hence, the intensity of light emerging from P3 will be I is equal to I naught cos square theta cos square pi by 2 minus theta, which equals I naught cos square theta sin square theta, which equals I naught by 4 into sin square 2 theta. Therefore, the transmitted intensity will be maximum when theta is equal to 45 degree or theta is equal to pi by 4. Let us have another example. Unpolarized light is incident on a plain glass surface. What should be the angle of incidence so that the reflected and refracted rays are perpendicular to each other? Let us have the solution. For I plus r to be equal to pi by 2, we should have tan I beta is equal to mu, which equals 1.5. This gives IB equals 57 degree. This is the Brewster's angle for air to glass interface. Let us have an example. Assume that light of wavelength 6000 angstrom is coming from a star. What is the limit of resolution of a telescope whose objective has a diameter of 100 inch? Let us have the solution. A 100-inch telescope implies that 2a equals to 100 inch, which equals 254 centimeter. Thus, if lambda equals 6000 angstrom, which equals 6 into 10 to the power minus 5 centimeters, then delta theta is approximately equal to 0.61 into 6 into 10 to the power minus 5 divided by 127, which is approximately equal to 2.9 into 10 to the power minus 7 radians. Let us have another example. For what distance is ray optics a good approximation when the aperture is 3 mm wide and the wavelength is 500 nanometers? Let us have the solution. The distance ZF equals a square by lambda, which equals 3 into 10 to the power minus 3 to the power 2 divided by 5 into 10 to the power minus 7, which equals 18 meters. This example shows that even with a small aperture, diffraction spreading can be neglected for rays many meters in length. Thus, ray optics is valid in many common situations.